We'll jump into the client functionality from the server connectivity class. I won't start with the UI and build everything up, but instead go through the code relatively quickly, as I'm assuming you've gone through the longer explanations in the previous modules. Like before, the server class abstracts the backend. I'll soon go into the details of the other classes in this package, which are property business object abstractions. As a reminder, notice that I import the CN class so I can use shorthand syntax for various APIs. I do this in almost all files in the project. Right now, the debug environment points at the local host, but in order to work with devices, this will need to point at an actual URL or IP address. As I mentioned before, we'll store the data as JSON in storage. The file names don't have to end in .json. I just did that for our convenience. This is a property business object we'll discuss soon. We use it to represent all our contacts and ourselves. This is the current WebSocket connection. We need this to be global, as we will disconnect from the server when the app is minimized. That's important, otherwise battery saving code might kill the app. This flag indicates whether the WebSocket is connected, which saves us from asking the connection if it's still active. If we aren't connected, new messages go into the message queue and will go out when we reconnect. The user logged into the app is global. The init method is invoked when the app is loaded. It loads the global data from storage and sets the variable values. Normally, there should be data here, with the special case of the first activation. If this is the first activation before receiving the validation, SMS, this file won't exist. In that case, we'll just initialize the contact cache as an empty list and be on our way. Assuming we are logged in, we can load the data for the current user. This is pretty easy to do for property business objects. If there are messages in the message queue, we need to load them as well. This can happen if the user sends a message without connectivity and the app is killed. Contacts are cached here. The contacts essentially contain everything in the app. This might be a bit wasteful to store all the data in this way, but it should work reasonably even for relatively large data sets. This method sends the content of the message queue. It's invoked when we go back online. These methods are shorthand for GET and POST methods of the REST API. They force JSON usage and add the auth header, which most of the server-side APIs will need. That lets us write shorter code. The login method is the first server-side method. It doesn't do much. It sends the current user to the server, then saves the returned instance of that user. This allows us to refresh user data from the server. We pass the current user as the body in an argument. Notice I can pass the property business object directly and it will be converted to JSON. In the response, we read the user, replace the current instance, and save it to disk. Signup is very similar to login. In fact, it's identical. However, after signup is complete, you still don't have anything, since we need to verify the user. So let's skip down to that. On the server, signup triggers an SMS, which we need to intercept. We then need to send the SMS code via this API. Only after this method returns OK, our user becomes valid. Update is practically identical to the two other methods, but sends the updated data from the client to the server. It isn't interesting. Send message is probably the most important method here. It delivers a message to the server and saves it into the JSON storage. Here we have the time in which a specific contact last chatted. This allows us to sort the contacts based on the time a specific contact last chatted with us. This sends the message using a web service. The message body is submitted as a chat message business object, which is implicitly translated to JSON. Initially, I sent messages via the WebSocket, but there wasn't a big benefit to doing that. I kept that code in place for reference. The advantage of using WebSocket is mostly in the server side, where the calls are seamlessly translated. The advantages of using web service is mostly that. If we are offline, the message is added to the message queue, and the content of the queue is saved. This method binds the WebSocket to the server and handles incoming and outgoing messages over the WebSocket connection. This is a pretty big method because of the inner class within it, but it's relatively simple as the inner class is mostly trivial. The bind method receives a callback interface for various application level events. For instance, when a message is received, we'd like to update the UI to indicate that. We can do that via the callback interface without getting all of that logic into the server class. Here we create a subclass of WebSocket and override all the relevant callback methods. Skipping to the end of the method, we can see the connection call and also auto reconnect method, which automatically tries to reconnect every 5 seconds if we lost the WebSocket connection. Let's go back to the callback method, starting with onOpen. This method is invoked when a connection is established. Once this is established, we can start making WebSocket calls and receiving messages. We start by sending an init message. This is a simple JSON message that provides the authorization token for the current user and the time of the last message received. This means the server now knows we are connected and knows the time of the message we last received. It means that if the server has messages pending, it can send them now. Next, we send an event that we are connected. Notice I used call serially to send it on the EDT, since these events will most likely handle GUI. This makes sense. Finally, we open a thread to send a ping message every 80 seconds. This is redundant for most users, and you can remove that code if you don't use Cloudflare. However, if you do, then Cloudflare closes connections after 100 seconds of inactivity. That way the connection isn't closed as Cloudflare sees that it's active. Cloudflare is a content delivery network we use for our web properties. It helps scale and protect your domain, but it isn't essential for this specific deployment. Still, I chose to keep that code in because this took us a while to discover and might be a stumbling block for you as well. When a connection is closed, we call the event again on the EDT and mark the connected flag appropriately. All the messages in the app are text-based messages, so we use this version of the message callback event to handle incoming messages. Technically, the messages are JSON strings, so we convert the string to a reader object, then we parse the message and pass the result into the property business object. This can actually be written in a slightly more concise way with the from JSON method. However, that method didn't exist when I wrote this code. Now that we parsed the object, we need to decide what to do with it. We do that on the EDT since the results would process to impact the UI. The typing flag allows us to send an event that a user is typing. I didn't fully implement this feature, but the callback and event behavior is correct. Another feature that I didn't completely finish is the viewed by feature. Here we can process an event indicating there was a change in the list of people who saw a specific message. If it's not one of those, then it's an actual message. We need to start by updating the last received message time. I'll discuss update messages soon. It effectively stores the message. ACK-message acknowledges to the server that the message was received. This is important, otherwise a message might be resent to make sure we received it. Finally, we invoke the message received callback. Since we are already within the call serially, we don't need to wrap this too. We don't use binary messages, and most errors would be resolved by auto reconnect. Still, it's important to at least log the errors. The update method is invoked to update messages in the chat. First, we loop over the existing contacts to try to find the right one. Once we find the contact, we can add the message to the contact. The find method finds that contact and we add a new message into the database. This is invoked when a contact doesn't already exist within the list of contacts we already have cached. The method closes the WebSocket connection. It's something we need to do when the app is suspended so the OS doesn't kill the app. We'll discuss this when talking about the lifecycle methods later. The contacts are saved on the contacts thread. We use this helper method to go into the helper thread to prevent race conditions. Fetch contacts loads the contacts from the JSON list or the device contacts. Since this can be an expensive operation, we do it on a separate contacts thread, which is an easy thread. Easy threads let us send tasks to the thread, similarly to call serially on the EDT. Here we lazily create the easy thread and then run fetch contacts on that thread, assuming the current easy thread is null. If the thread already exists, we check whether we already are on the easy thread. Assuming we aren't on the easy thread, we call this method again on the thread and return. All the following lines are now guaranteed to run on one thread, which is the easy thread. As such, they are effectively thread safe and won't slow down the EDT unless we do something that's very CPU intensive. We already have the data we use call serial. If we already have the data, we use call serially on idle. This is a slow version of call serially that waits for the EDT to reach idle state. This is important for performance. A regular call serially might occur when the system is animating or in need of resources. If we want to do something expensive or slow, it might cause choking of the UI. Call serially on idle will delay the call serially to a point where there are no pending animations or user interaction. This means that there is enough CPU to perform the operation. If we have a JSON file for the contacts, we use that as a starting point. This allows us to store all the data in one place and mutate the data as we see fit. We keep the contacts in a contacts cache map, which enables fast access at the trade-off of some RAM. This isn't too much since we store the thumbnails as external JPEGs. Once we loaded the core JSON data, we use call serially to send the event of loading completion. But we aren't done yet. We loop over the contacts we loaded and check if there is an image file matching the contact name. Assuming there is, we load it on the contact thread and set it to the contact. This will fire an event on the property object and trigger a repaint asynchronously. If we don't have a JSON file, we need to create it, and the place to start is the contacts on the device. getAllContacts fetches all the device contacts. The first argument is true if we only want contacts that have phone numbers associated with them. This is true as we don't need contacts without phone numbers. The next few values indicate the attributes we need from the contacts database. We don't need most of the attributes. We only fetch the full name and phone number. The reason for this is performance. Fetching all attributes can be very expensive, even on a fast device. Next, we loop over each contact and add it to the list of contacts. We convert the built-in contact object to chat contact in the process. For every entry in the contacts, we need to fetch an image. We can use call serially on idle to do that. This allows the image loading to occur when the user isn't scrolling the UI, so it won't noticeably impact performance. Once we load the photo into the object, we save it to storage as well for faster retrieval in the future. This is pretty simplistic code. Proper code would have scaled the image to a uniform size as well. This would have saved memory. Finally, once we are done, we save the contacts to the JSON file. This isn't shown here, but the content of the photo property isn't stored to the JSON file to keep the size minimal and loading time short. Once loaded, we invoke the callback with the proper argument. When we want to contact a user, we need to first make sure he's on our chat platform. For this, we have the Find Registered User Server API. With this API, we will receive a list with one user object or an empty list from the server. This API is asynchronous, and we use it to decide whether we can send a message to someone from our contacts. This is a similar method that allows us to get a user based on the user ID instead of a phone. If we get a chat message that was sent by a specific user, we will need to know about that user. This method lets us fetch the metadata related to that user. The chats we have open with users can be extracted from the list of contacts, since every contact has its own chat thread. So to fetch the chats we see in the main form of the WhatsApp UI, we need to first fetch the contacts as they might not have been loaded yet. We loop over the contacts, and if we had activity with that contact, we add him to the list in the response. But before we finish, we need to sort the responses based on activity time. The sort method is built into Java Collections API. It accepts a comparator, which we represented here as a lambda expression. The comparator compares two objects in the list to one another. It returns a value smaller than 0 to indicate the first value is smaller, 0 to indicate the values are identical, and more than 0 to indicate the second value is larger. The simple solution is smaller. The simple solution is subtracting the time values to get a valid comparison result. We saw the ACK call earlier. This stands for acknowledgement. We effectively acknowledge that a message was received. If this doesn't go to the server doesn't know if a message reached its destination. Finally, we need this method for push notification. It sends the push key to the device to the server, so the server will be able to send push messages to the device.